There is a product that costs $5 at any drugstore that erases leather seat cracks permanently. Not fills them temporarily, erases them. Those deep stress cracks spreading across your driver's seat that make a $40,000 vehicle look like it survived a decade of neglect. The spiderweb fractures radiating from the bolster seams where your body slides in and out every single day. The embarrassing splits along the headrest that scream wear and tear to anyone sitting in your back seat. Automotive upholstery shops charge $500 to $2,000 per seat for leather repair or complete reupholstery. Professional leather repair kits sold at auto parts stores promise restoration for $50 to $150 but require heat guns, color-matching compounds, and grain texture stamps that most car owners do not own. One application of this common household product fills cracks at the molecular level, restores flexibility to dried leather, and color matches perfectly when heat activated. The automotive interior restoration industry generates billions annually from a problem that basic chemistry solved over a century ago. A tube of shoe polish sitting on the pharmacy shelf for $5 cannot justify the specialized certification programs and proprietary repair systems that upholstery shops use to maintain pricing power. This is the story of the wax compound that repairs leather cracks and the upholstery trade that built an empire on your belief that cracked leather is permanent damage. Welcome to my channel. If you are not subscribed yet, hit subscribe and the bell. This is where we reveal what billion-dollar industries spent generations concealing from ordinary car owners. Now here is where this material weakness was engineered into the product. In 1924, Cadillac became the first American automaker to offer genuine leather upholstery as standard equipment on production vehicles. The material was sourced from European tanneries that processed full-grain cowhide using vegetable tanning methods developed during the Industrial Revolution. Full-grain leather contains natural oils called lipids that keep the material supple and resistant to cracking under flexion stress. These oils are embedded throughout the collagen fiber structure during the tanning process. Vegetable tan leather could last 30 to 40 years in automotive applications before showing significant structural degradation. But vegetable tanning required 6 to 12 months of processing time and expensive tannin extracts from tree bark. As automobile production volumes exploded through the mid-20th century, manufacturers demanded faster, cheaper alternatives. In the 1960s, chrome tanning replaced vegetable methods across the automotive supply chain. Chrome tanning uses chromium salts to cross-link collagen fibers in a process that completes in 24 hours instead of months. The material cost dropped by 60% and production throughput increased exponentially. But chrome tan leather contains significantly fewer natural lipids. The rapid chemical process does not allow oils to penetrate deeply into the fiber structure. The leather emerges from tanning already partially dried compared to traditional methods. Modern automotive leather receives a protective top coating to compensate for the reduced oil content. This coating is a polyurethane film applied to the surface that acts as a moisture barrier and UV shield. The coating lasts approximately 3 to 5 years under normal use before breaking down from friction and sunlight exposure. Once the coating fails, the leather beneath is exposed and vulnerable. The driver's seat experiences the highest stress concentration of any upholstered surface in the vehicle. Your body weight creates compression stress every time you sit down. Lateral forces develop as you slide into position. Flexion stress occurs as the leather bends around the seat bolster during entry and exit. This repetitive mechanical loading causes the dried leather fibers to fracture. Cracks form along stress concentration lines, typically starting at seams and spreading outward in characteristic spiderweb patterns. The cracks expose the internal fiber structure to air and moisture, which accelerates deterioration. Most vehicle owners assume cracked leather requires professional repair or complete replacement. Upholstery shops reinforce this belief by describing the damage as structural failure requiring specialized intervention. The repair process they sell involves grinding away damaged material, filling voids with vinyl compound, applying heat to fuse the filler, color matching with pigmented coatings, and stamping artificial grain texture to blend with surrounding leather. This labor-intensive process justifies prices between $500 and $2,000 per seat depending on crack severity and vehicle type. Luxury vehicles command premium pricing, with some shops charging over $3,000 for complete front seat restoration. But the fundamental chemistry of leather crack repair is identical to shoe repair, a craft that existed long before automobiles. Shoe polish contains 3 primary ingredients: wax, oil, and pigment. The wax component is typically carnauba, beeswax, or paraffin. When heated, wax becomes liquid and can penetrate porous materials through capillary action. As it cools, the wax solidifies and creates a flexible filler that bonds to surrounding material. The oil component moisturizes dried leather and restores lost lipids to the collagen fiber structure. The pigment provides color matching. When you apply shoe polish to a leather crack and activate it with heat, the wax melts and flows into the fracture. The crack acts as a capillary channel that draws liquid wax deep into the damaged area through surface tension. As the wax penetrates, it displaces air and fills voids completely. Cooling causes the wax to solidify into a flexible plug that bonds chemically to the leather fibers. The oil simultaneously rehydrates the dried collagen and restores flexibility to the surrounding material. The pigment ensures visual color match with the original leather tone. A 2014 study published in the Journal of the American Leather Chemists Association tested various crack repair compounds on artificially aged automotive leather samples. Researchers at the Leather Research Laboratory in Cincinnati exposed chrome-tanned leather to accelerated aging equivalent to 10 years of automotive use. The aged samples showed typical stress cracking and fiber separation. They applied shoe polish containing carnauba wax and neatsfoot oil to half the samples and professional vinyl filler compounds to the other half. After heat activation and 30-day curing, mechanical testing measured crack closure, flexibility recovery, and bond strength. The shoe polish treatment achieved 89% crack closure with flexibility scores matching undamaged leather. The professional compounds achieved 94% closure but remained rigid, scoring only 34% on flexibility tests. The study concluded that wax-based treatments restored both structural integrity and material properties, while synthetic fillers provided superior cosmetic results at the cost of leather flexibility. The global automotive upholstery repair market generates over $4.8 billion annually. Leather crack repair represents approximately 35% of that revenue, roughly $1.7 billion per year. The average repair cost per vehicle ranges from $612 to $100 depending on the number of seats requiring treatment. Mobile repair services have grown significantly, with technicians operating from vans and charging premium rates for on-site convenience. Some franchises generate over $300,000 annually per vehicle with overhead costs below 20%. The business model depends entirely on customer belief that leather repair requires professional expertise and specialized materials. A $5 tube of shoe polish threatens that perception. Here is the method upholstery shops will never mention. Purchase shoe polish that matches your leather color from any drugstore or shoe store. Neutral polish works for most leather tones, but brown and black are available for precise matching. Cost ranges from $3 to $7 per tin. Clean the cracked area with isopropyl alcohol on a cloth to remove oils and surface contamination. Let dry completely. Apply shoe polish directly into the crack using a cotton swab or small brush, working the paste deep into the fracture. Overfill slightly so polish mounds above the surface level. Use a hairdryer on high heat setting held 2 inches from the surface. Heat for 30 to 45 seconds until you see the polish begin to glisten as the wax melts. The melted wax will be absorbed into the crack through capillary action. You will observe the mounded polish settling as it penetrates. Continue heating until absorption stops. Let cool for 5 minutes. Wipe away excess polish with a clean cloth. The crack will appear filled and color matched. For deep cracks, repeat the application after the first layer cools. Build up the repair in multiple thin layers rather than one thick application. After final application cures for 24 hours, buff the area with a soft cloth to blend shine with surrounding leather. A software developer in California documented this process on a 2017 BMW with severe driver seat cracks spreading from the bolster seam. An upholstery shop quoted $1,400 for professional repair. He purchased brown shoe polish for $6 and completed the repair in 40 minutes using a hairdryer. 3 years later, the repair remained intact with no crack reappearance. Knowledge like this does not disappear because it fails. It vanishes because it cannot generate recurring revenue. Subscribe and share this with every car owner still paying hundreds for leather repair that shoe polish solves permanently.